Welcome dear students. In this lecture, we are going to see the difference between the polar and non-polar bonds. First of all, keep one thing in your mind that the concept of polar and non-polar bonds is only applicable to the covalent bonds. It is not applicable to the ionic or coordinate covalent bonds. Now, my dear students, there are two chances. The first one is that is a covalent bond is formed between two identical atoms. When the covalent bond is formed between two identical atoms, here the difference of electronegativity that will be 0. And when the difference of electronegativity is 0, it means there will be equal distribution of bonded electrons between two atoms. So the molecular orbitals of the two bonded atoms, they will be having same electron density. For example, if the bond is between two hydrogen atoms, the electronegativity of this hydrogen that is 2.1 and the electronegativity of the other hydrogen that will also be same. So here the difference of electronegativity will be 0. And when the difference of electronegativity is 0, it means the electronic density will be equally divided between two hydrogen atoms, and the molecular orbitals of both these hydrogen atoms, they will be having equal electron density. When they have equal electron density, then my dear students, there will be no positive or negative end of that molecule, and this bond between the two hydrogen atoms, that will be called as the non-polar covalent bond. And this hydrogen molecule, that will be a non-polar molecule. Now, my dear students, the second chance is that the covalent bond is present between two different atoms. If the covalent bond is present between two different atoms having different electronegativities, then the difference of electronegativity will not be equal to 0. And when the difference of electronegativity is not 0, it means the bonded electrons will not be equally distributed between the two bonded atoms. Rather, the atom having higher electronegativity will be having higher electron density in its molecular orbitals as compared to the atom having low electronegativity, which will be having low electron density in its molecular orbitals. For example, let us consider the example of the bond between carbon and chlorine. My dear students, the difference of electronegativity here, the electronegativity of carbon is 2.5 and that of chlorine is almost 3. So the difference of electronegativity here, that is 0.5. The chlorine is having more electronegativity, carbon is having low electronegativity. So the shared pair of electrons, they will be more tilted towards the chlorine atom. And now in this case, this is carbon atom, here is the chlorine atom. So most of the electronic density that will be around the chlorine atom, its molecular orbitals will be having greater electron density as compared to the carbon. In that case, the carbon will be having very low electron density. So like this, the atoms will be bonded, but the bonded electron density that will be more in the molecular orbitals of the chlorine. Now in this case, due to unequal distribution of the electron density, the atom having low electrons in its molecular orbitals will get delta positive charge, and the atom having more electrons in its molecular orbitals will get delta negative charge. Here delta, that is a Greek symbol which means small. So there will be small positive charge on the carbon atoms, and there will be a small negative charge on the chlorine atom. And this bond, because it has two poles, one is the positive pole, other is the negative pole, so it will be considered as the polar covalent bonds. It will be considered as the polar covalent bond. But my dear students, there are some molecules which have polar covalent bonds, but still they are non-polar because their dipole moment is zero. We will arrange a separate lecture in which we will be discussing the polarity of the molecules. Because polar and non-polar bond and polar and non-polar molecules, these are two different concepts. A molecule may have polar bonds, but still overall the molecule might be non-polar. But as far as the difference of electronegativities is concerned, it is recommended by the IUPAC that from 0 to 0.4, if the difference of electronegativity between two bonded atoms is from 0 to 0.4, that will be considered as non-polar covalent bond. A bond will be considered polar if the difference of electronegativity between two bonded atoms that is greater than 0.4. Just like the bonds between carbon and hydrogen, with you commonly see these bonds in the organic molecules, the difference of electronegativity between these two bonded atoms is 0.4. So that is why that bond will be considered as the non-polar bond, because here this small charge is very very micro on the two atoms, mean this delta positive and delta negative, that is very very small in magnitude. So that bond is considered as the non-polar bond. That is why in case of alkanes you say that there are carbon carbon bonds and carbon hydrogen bonds. Carbon carbon bonds, they have difference of electronegativity equal to 0, so they are non-polar. But carbon hydrogen bonds are also considered as the non-polar because the difference of electronegativity is 0.4, that is less than you can say 0.4 is the main barrier. So if the electronegativity difference is greater than 0.4, then the bond will be considered as the polar. If the difference of electronegativity is up to 0.4 or less than 0.4, then the bond will be considered as the non-polar covalent bond. So it was all about the polar and non-polar covalent bonds.